Still no Matt, no Chandler.
And
Matt Chandler's gonna be gone for a couple because
dang, where's Matt?
He might be online.
He's online.
The only one that was online yesterday was Isaiah. All right. Questions? Easy, hard, what? Hopefully. Like I said, we're going to be using that every day. Like our answers are all going to have square roots in them for this chapter, and so you're going to have these techniques down. All right, page 280. We're way over halfway through the book. We're making great progress this year. Yay!
Don't sound so. Come on. Be happy with.
All right.
Sorry.
Number 2, the answer is
Number 2 is 3.
what?
how'd you get 3?
How'd you get
boy?
3
That's
out of the
9.
square root of 81?
That's 9.
Oh yeah, because I square rooted 9 after that.
Why would you do that?
I don't know. I have
I almost think that's I really close.
All right. Number 4, Seth, the answer is?
probably not the answer.
Well, let's see.
I have 7, which is probably the square root of the answer.
Yeah, but you forgot the square root of 2. 7, square root of 2.
Oh, I actually did get that.
Okay.
Oh yeah.
What did you get for number 6, Seth?
Square root 1 over 2.
What's the square root of 1? What times itself is 1?
1.
So therefore, what's the square root of 1? So it's not the square root of 1 over 2. It's, there you go. It's 1/2. You had the square root of inside 1/4. So you take the square root of the top, square root of the bottom. The square root of 1 is,
1.
so that turns into 1. Square root of 4 is, so 1 over 2.
So that's why 0 is the square root. Because square root is
It is,
0.
right. Number 8, first challenging one. This would be 4 root 5. Pretty comfortable with me saying that? 4 root 5 over 5.
Yes, sir. Yeah.
How did you get that one right with the square root of 81 wrong?
I don't know, man.
Number 10, 5 root 30 over 12. I mean,
Yes.
sometimes these numbers get ridiculous. And what I said yesterday was we can have our calculator be our friend to help us, but you got to have those perfect squares in your head. Number 12 is just plain old. Had a bunch of people ask me that question as soon as I explained, like, oh, okay, that was easy. Number 14 is 72. Number 16 is 15 root 2. 15 root 2. So the square root of 18 is 9 times 2. That would be 3 root 2. And 3 times 5 is 15. Number 18 is 12 root 6. Number 20 is 18 root 10. Number 22 is, correct? She said 3. 24 is the square root of 7. That wasn't very satisfying, that one. Number 26 is 5 root 3. And 28, the answer is? No, that one actually does.
5.
It is, let's see who's right. I heard 3, 5, 7. Let's see who's right.
I got no.
And no solution. So we have x squared plus 5 squared. Why is this supposed to be is equal to, it's got parentheses, 5 square root of 2, and the whole thing is squared. All right, well, 5 squared is clearly, so that's x squared plus 25. This probably won't work either. All right, what does squaring do?
The numbers
By itself. So this goes to everything on the inside. Well, there's a 5 here, so that's going to turn that 5 into a, well, that's the easy part. And what does squaring do to square rooting?
Cancel.
So you're just left with what, when you square a square root, you're just left with what's underneath. What's underneath? Times 2. See what it did?
50.
So you get x squared plus 25 is equal to 50. Subtract, you get x squared is equal to 25. How do you get rid of squaring?
Multiply by x or divide by
Square root.
It's not dividing, we take the square root. Both sides, therefore x is equal to, whoever said 5, which I think it was Micah, Cadence. Oh, Seth. Seth, you were right. You got the hardest one right and the easiest one wrong. That is just mathematically frustrating.
I like it to be backwards.
I watched this. Speedrun can be hard.
All right. Seth, collect. That's your punishment.
But I got the hard one right.
I know. But you got the square root of 81 wrong.
9 times 9.
The square root of 81 is 3.
See why some fact checkers say this.
All right. That did erased very poorly. I both love the day today and I dread today. We're going to do something that a couple of you are going to find ridiculously easy and get it immediately. And we're going to do something that some of you will struggle with until the test, and you'll still probably get it wrong. So I'm just going to warn you ahead. We're going to do 8.1 today. I'm going to warn, here's your homework. I'm just going to warn you that it's not truly that what we're going to do is complicated. It's actually easy, and I know it's me saying it's easy. What we're going to do is something that's complicated. It's got some steps. It's got some diagrams you got to draw. But in the big picture, it's actually pretty easy. Like nothing that we're going to do today is hard. There's 3 basic things. I usually will get 3 kids out of a class that will be able to do this backwards and forwards and have it memorized. And then I'll have 3 to 4 kids that they don't even know that they're in a geometry class. So I am exaggerating slightly, but I just encourage you that there's a class that you pay attention to. It's this one, right? And you really try to get it on your first shot. It's truly not that hard, but it is different, a little bit complicated. The chapter is on right triangles, and it's my favorite chapter of the entire book. And the thing that we're going to learn today, there's 3 basic skills we use throughout this chapter. If you ever get a test like the one you're about to take on NWEA, I bet it's on the test as well too. There's only a few things in geometry. I mean, we learn lots of things. There's only a few things that they usually have on every single geometry test, and this is one of them. All right, similarity and right triangles. The last chapter was on similarity. Triangles, these are specifically just right triangles and similarity. All right, my favorite chapter. Hey, I even wrote that. All right, recall cross products, right? Cross multiplication, we've done this before, right? Right, big fancy words for 2 fractions with an equal sign, you're always allowed to cross multiply. And then math teachers make it more complicated. They have words. Right, here's your first. Like I said, this is easy. Some kids will get it like that, and other kids are like, you lost me at the words means and extremes. They're just words. Okay? Remember, ratios, fraction, can be written 2 ways. They can be written in fraction form, 4 ways actually. They can be written in fraction form, and they can be written in colon form. Here's your first. Okay, you got to make sure you're with me. This fraction a over b could be written as a colon b, right? Therefore, c over d could be written as c colon d. We give names to these letters. The letters that on the colon form appear at the very ends, we call the extremes. We call the middle ones, we call the means. That's great in ratio form, but on fraction form, well, the means are these 2, and the extremes are these 2. That's all this slide says. It has little importance at this point for what we're about to do, except the fact that I'm going to use this word means here in a second. You with me? I'm going to use this, and then throughout this, the other 2 skills, I'm going to use this word means again. All right. What am I saying here? Cross multiplication works. All right. What would happen if I took this, and instead of it saying BC, it said XX? In other words, I'm going to make the means exactly the same. Instead of being different, B and C, I'm going to make them both the same number, same variable, X. Okay? That's all I did. All right, Karis, let's do some cross multiplication. Tell me what the cross multiplication for this one would be. Like, what would I need to do if I wanted to cross multiply? Times and That's all we're saying, right? X times X is equal to A times B, right? Remember, the means are these two. It's just a word, means. So when the means are exactly the same, XX or 4 and 4 or -1, -1, that's the scenario that we're in. The means are exactly the same. Okay? Well, if we did the math, X times X is X squared, right? This chapter involves right triangles and square roots, kind of see where we're going. So from last night's homework, okay, so what do we do to solve this? I take the square root of both sides. I don't want you to get hung up on this plus or minus right here. We throw this in here at this point just so you understand there's two numbers that when you multiply, you get to another number, right? If I threw some numbers up here, let's say the answer here is 36, A times B is 36. There's two numbers that when you square, you get to 36. 6 and that's why this plus or minus lives here. Okay, when you take the square root, you didn't do this last night, technically the answer is plus or minus. You guys remember the quadratic formula? Very last thing you did probably, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a, that big long formula. Because you take the square root of both sides, you get a plus or minus. But this course this year is called
Geometry.
in geometry. Can you ever have a side length of -2? I take a box and I measure it, could I ever have -2? I can't. So we're going to hold this plus or minus for next year, algebra 2, and we can't have negative values. We can't have negative values this year because links are not negative. So even though it's true, it's plus or minus, we're going to ignore the minus, and we're just going to say square root of AB. So what just happened? If you have a proportion, ratios, two ratios that are equal, where the means are exactly the same, you get that thing, cross products are equal. And then when you solve it for X, you get that thing right here. This is what the whole lesson is on today, this step right here. That X would be equal to the square root of A times B. Okay? We give this a name. That just sounds like I'm Italian. We give this a name. We give this a name, and we call this, they call it the geometric mean. Well, why do they call it the mean? Well, it came from the means. And why do they call it geometric? Because remember, mean has a different, another meaning, pun intended. We have what's called the arithmetic mean, right? If I ask you to calculate your grade, guess what you do? You add up all your grades and you divide by how many you have. That's called the arithmetic mean. That's how you find the mean.
Okay.
The geometric mean, it's kind of not the same. You find it out by multiplying instead of having. Okay? All right, so this is called the geometric mean. Big picture here, it's this turns into this. All I'm doing is taking this and solving it. All right, write this down, please, box 1.
English is weird. I'm over here like meaning, like the
Yeah, there's lots of
or
right.
geometry or meme or what is
A geometric mean is simply the square root of the product of two given numbers. I give you two numbers, you take the square root of their product, you have what is called the geometric mean. It's the previous slide, just the end result. You take the square root of two numbers that are multiplied. This is skill number 1 today. This is the easiest of the 3 skills. You just take two numbers, you multiply them, and you take the square root, and you're done. Why would you do that? Because it's that proportion we just set up. But that's called the geometric mean. You take two numbers, 4 and 9. What's it say to do? No, what's it say to do? That means what? That means times them. 4 times 9 is, and then you. I don't know why kids get lost on this when I say, tell me the geometric mean, but that's all I'm asking you to do. Multiply, square root. What's the answer for this one? And you're done. Okay, that's not that hard. Yet I will ask you on the test, tell me the geometric mean of 4 and 9, and I'll have people put question mark. Like, I don't remember what to do. Multiply, take the square root, and you're done. That's called the geometric mean. The arithmetic mean, you add the 2, 4 plus 9, you divide by 2. Geometric mean, you multiply, you take the square root. Okay, you tell me, easy or hard? This is easy if you understand what's going on. It's, I don't know what to do if you weren't paying attention. Just multiply the numbers, take the square root. Done. So we don't need to do, are we okay? This is what it'll look like tonight for homework. Literally, they'll give you two numbers and they'll say, what's the geometric mean? Connor, what's the first step? So what's 3 times 10? Second step, Bailey? He said 3 times 10. You just take the square root of that product. All right. I'm going to show you complicated. What we just did right there is the answer, by the way, but I'll show you complicated. Right? Geometric mean is you mean times mean is equal to A times B, and then you take the square root. Okay? So if we set it up, right? What is the geometric mean between 3 and 10? It's asking you to do x times x squared. 3 times 10 is 30. But in reality, take the two numbers, multiply them, take the square root. Remember, the plus or minus in algebra literally does exist, but since we're in geometry land, we ignore the minus. So it's the square root of 30. By the way, we got to remember from yesterday, any perfect squares go into 30, you're done. Okay? Do you need to do all this? No. That's the step you need to do. Take the square root of the two numbers, multiply together, and you're done. So that's just explanation of why it works. No, you don't need to do all that. That's called the geometric mean. So that's what you'll do. And then you're done. So let's do box 2. Danny, what's our first step? Okay, 5 times 11 is? And then you take the square root of that. Okay, 5 times 11 is?
55.
Is there any perfect squares inside of 55?
Good chance there's not.
1, 0, right? But other than that, and that doesn't get us anywhere. So yeah, you're done. Tonight for homework, there'll occasionally be some perfect squares inside that you'll have to reduce. I'm not sure why I gave you this one because it's the same one as the example. I gotta change that. 9 times 4 is?
36.
The square root of 36 is? I mean, I'm not going to even claim that I would mark it off if you just wrote the answer as 6 for this one, right? Because that one is a pretty simple one. All right, who's lost? Boy, if all geometry was like this, it would be nice. There's a big but here. And the big but is that occasionally 4 times 8 is?
32.
Okay. What's the problem? There's a perfect square inside of 32. That perfect square is?
4.
You agree, Karis? He said 4. You were doing so well yesterday. You were the one that said, no, it's not 4. This literally was the one that you had yesterday. Or maybe it was Bailey. One of you said the right answer. By the way, 4 works. It's not wrong, Wes. 16 is the largest perfect square. And you said that yesterday, right? You're like, no, 16 is the biggest one. But 4 would work. It would just take us 2 steps. But if you know that it's 16 right from the very start, then you know your life is a little bit easier, right? One less step. All right, did I lose anybody on that one? Okay. We good? I said we're doing 3 skills today. There's skill number 1. That ain't that bad, right? It pains me that we get to test day and I have students that can't do that. I'm just going to tell you straight up. This is question number, 12 on the test. And I'll have kids that put question mark because they I don't remember how to do that. Right? It's in your notes. You're going to do it tonight for homework. You shouldn't forget this. All right. So I'm going to still say the stuff we're about to do is easy, but I also realize that for some of you, it's going to take a while for you to realize how easy it is. So but once you realize how easy it is, it won't be hard for you anymore. Okay? So here we go. Toughest stuff that we'll do today. We got to do a proof first. All right, here's the proof. All right, for this entire section, this is the basic idea. You start off with a right triangle that's on its, I don't know if you want to call it the side, but you start off, everybody look at the board. This is the right triangle you start with. And then from this, you create, I don't know if you remember what an altitude was. An altitude is a segment, a line, that goes from a vertex of a triangle perpendicularly down to the opposite side. So that's the basic shape that we have. We got a right triangle and we got an altitude. And the altitude specifically goes to its hypotenuse. Okay? So what is it asking us to prove here? It's asking us to show that apparently there's three triangles here and that they're all similar. Everybody see that?
Yeah.
Well, where are the three triangles? I only see two triangles.
The really big one.
Oh,
And then,
you got the outside one. That's one right triangle.
And then C and B.
I'll call that the big triangle. And then you got this one. I'll call that the,
Little triangle.
and then I'll call this one the,
Medium triangle.
that's what I use. So I got big triangle, little triangle, medium triangle. Okay? All three triangles are the right triangles, right? If this is 90, that side's 90. Supplementary. The big triangle we said was right triangle. Okay, so we got three right triangles, but they're formed from one right triangle where you drop an altitude down to the hypotenuse of it. Are we okay with the name hypotenuse? The side that's opposite the right angle? Okay. Somehow these are all similar. Oh, this is an easy proof, by the way. Looks like it would be hard. It's pretty easy. Okay. So there's a lot of ways to tackle this, but how about we just make it a little bit easier and we just, instead of considering all three of them, just two at a time. Okay. So I'm only going to try to show two at a time are similar. And we'll see how that works. Okay. I need to show that all three are similar to each other. But I'm going to start off with the fact that all the right angles are equal to each other. Is that true? Right? Because 90 equals 90 equals 90. So that's 90, that's 90, and that's 90. That's all I'm saying right there. Is that all the right angles are equal to each other. By the way, who remembers, and this is a while ago, how do we show that two triangles are similar? We got A, anybody? We got AA, we got, there's two more. SAS, and we have SSS. Okay, those are the only three we have. Okay, so it's going to be one of those three. Guess what I just showed? Did I show a side or an angle? I showed an angle. So I got an angle. So if I show one other angle, I'm done. Okay, so here's the trick. Let's look at, I'm just picking two at random. And hopefully I picked the right two. I forget if I picked, I think the first one is the small one and the big one. Actually, I think I did medium. If I remember right. I should have reviewed this. Let's look at the medium one. The medium one and the big one. I highlighted the medium one. Notice that the medium one and the big one share B. To show that two triangles are similar, I just got to show that two angles are congruent, and I just did. Hopefully I did that. CBN, yes, good. So CBN is congruent to CBN by reflexive property, right? So now I just showed that two angles of one triangle are congruent to two angles of another one, therefore the two triangles are similar. I will just choose ABC, that's the big triangle, to CMB, the medium one. Okay. So I just showed that medium is similar to big. Cool. AA. Well, if I did that trick for medium to big, I could probably also use that trick for big to small, because the big and the small, here's the small, both share angle A. So I'll do that same trick that I did right here. I'll just say, I could have said angle A, right? Angle A is congruent to angle A. Why? Because it's reflexive. And that angle A is shared with both the small triangle and the big triangle. Therefore, the small triangle is similar to the big triangle. And it turns out that's it. That's all I need to do. Just check out. I went big to medium, and I went big to small, right? And if both the big and the medium and the small are similar to the big, then all three of them are similar. That's the transitive property. If A is equal to B and B is equal to C, then A is equal to C. That's what I just showed. I showed that the big is the same as the medium. And I showed that the big is the same as the small, or similar, I should not say the same. Therefore, the small and the medium have to be the same as well, too. All right, done. This is the most unused proof in the book. So why did I just do that? Because from this, we get two of the most useful theorems of the book. Okay, so this one that we did right here, by the way, this does need to go in your book of truth. This is Theorem 8.1. Make sure this goes in your book of truth. This is Theorem 8.1. It's the most unused theorem of the book, but it gives us from it two very important things. All right, all it's basically saying is that if you have a right triangle with an altitude to its hypotenuse, that the three triangles formed are all similar to each other. That's what we just proved. So that's 8.1. But remember, it's got to involve right triangle, not just any triangle. It's got to be right triangle. You start with a right triangle, you make an altitude to its hypotenuse. The three triangles formed are all similar to each other. Seth, are you trying your homework?
Huh?
Are you trying your homework?
Trying?
Yeah.
Doing it.
I get your point. Don't try numbers. Anything beyond 21.
I can write down all the notes and I read it.
Do you understand it?
Yes, actually.
Okay.
Well,
What's
yeah,
the square root of 81?
Square root of 81 is 9.
I was just going to ask that.
51
should have been 5 seconds faster.
C is
All right.
all that kind of stuff. And a bunch of current.
All right, so Theorem 8.1, altitude from a right triangle to its hypotenuse. Then the two triangles form. That's three, right? Because you consider the big one. All three triangles are similar, even though it's just two. It's talking about the two that are formed from the altitude. If me, and I took this from the book, I would have written it as then the three triangles formed are similar to each other. All right, we okay? I said this one is never used again, except what we get something from it. So not very useful in itself, but we're going to get two corollaries from it, and boy, are they useful. Remember, just so you understand, corollary is theorems that drop immediately from a given theorem that we just proved. So all three that we're about to do, it's technically just two, corollary 1 and corollary 2, but there's two parts to 2. They come right from this Theorem 8.1, okay? So this is Corollary 1 to Theorem 8.1. All right, I'm going to talk about small to the medium triangle. So I'm talking about this triangle to this triangle, this triangle to this triangle. Hey, what does the small triangle and the medium triangle have in common?
Right angles.
Say again?
I just said right angles.
They both have right angles. There's just two things. And, go ahead, Karis. They share CN. So they share a side, and they're both right triangles. Okay.
They also share V.
So if that's true and they're similar, from the previous chapter, we get to say, don't write down anything yet, we get to say that their sides are in proportion. I'm going to choose the sides. Watch the ones I choose. Right? I'm going to say that AN, that's the small leg of the small triangle, compared to the long leg of the small triangle. That's the, see, and I'm going to follow the same pattern on the medium one. So I went small to big leg. So I do the same thing on this triangle. That would be this to this. I'm skipping the hypotenuse. That's the proportion. I said, don't write down anything yet. What do you notice about this proportion?
It's just like the one on the lower, like.
What do you notice it has in common? Karis already has this. Say it out loud, Karis. They both have CN. Hey, this is a geometric mean. So the geometric mean says that CN would be equal to the square root of that times that. That's what I want you to write down. By the way, in the book, they don't write this down. Guess what you need for homework? This is great. It's true. But what's in yellow is what you need. I don't even care if you skip this on your book of truth. This is what you need to write down. This is what's the useful bit of information. Yeah, you can write this down, but this in yellow is the useful bit. You have to have this picture drawn, though. You're going to draw this twice. Draw that picture. The words are great and all that, but the picture and what's in yellow are the important thing. If you have a right triangle with an altitude, the altitude is equal to the square root of this little piece times this, I don't know what you want to call it, medium piece. That's how I think of it. Triangle's got to look like this. But if you want to solve for the altitude, how long is the altitude? You take the square root of this little piece times that little piece, and you're done. That's the useful thing. By the way, we just proved this, right? How did I prove it? Well, this is the construction. From 8.1, we know that the two triangles are similar. If they're similar, then I can set up their sides in a proportion, and then I just did a little bit of algebra to get to that. I mean, technically, I just proved corollary 1. That's why we're not going to officially prove this one, because we proved it. So what did I say was an important thing to remember? You got to remember the picture. Looks like that, and you got to remember what's in yellow. Guess what they're going to give you tonight for homework? They're going to give you this picture with some numbers and some variables and ask you to solve for them. You're going to use this right here, but you got to be able to apply that picture and this equation to that scenario. We'll do, I think, 3 examples on your paper in front of you. This is corollary 1. You get one thing from corollary 1. This thing right here, that the altitude is equal to the, you got to come up with descriptive terms. I always say little piece times medium piece. Notice, here's the hypotenuse. Here's the hypotenuse. Corollary 1 doesn't touch the hypotenuse. A times Bn is the hypotenuse of the big one. So some people think of that as the altitude is equal to the hypotenuse of the big one, the pieces parts multiplied together, if that helps you. Okay. Corollary 2 gives us 2 things. Okay. Starts with altitude, if that helps as well too. All right, very useful. Corollary 2 is going to give us 2 things. I don't know why they wrote, I would have wrote corollary 1, 2, and 3. They chose to do this as both these as one corollary. All right, if corollary 1 does small to medium, corollary 2 does small to big and medium to big. Okay? It's basically the same idea. You get 2 triangles are similar. We set up a ratio, a proportion, I'm sorry, and then we get a geometric mean out of them. Okay? So here's what it says. If we do small to big, so I'm doing small to the whole thing, that the hypotenuse of the small, right, AC, right, is equal to, okay, here's where it gets a little bit, you're lost, is equal to the whole long hypotenuse of the big, right, that's the AB, times the shorter leg of the small. Okay, that's where I start losing kids. They're like, those are just names and words. You got to visually understand the pieces parts. So yellow is what, again, the most useful thing. So let's look at this one. AC is the hypotenuse of the small, and it's equal to the square root of the big one's hypotenuse, that's AB, times this piece. For some reason, this pattern really sticks with me. This piece is equal to the square root of the whole thing times this piece. Notice that both of these pieces, both AC and AN, are on the left side. That's how I kind of remembered it in high school.
So AC is the square root of AB times AN.
Correct. But the issue is that how do you remember this? So for me, it was, if I start over here, I'm going to use this piece and the whole piece. That's how I kind of remember. The nice thing is this, tonight for homework, once you do maybe, I don't know, 7 or 8 of these, maybe it starts sticking with you, maybe it doesn't ever stick with you. But the nice thing is that you're always going to have this picture. And if you're ever asked, oh, I remember the picture, hey, I got an altitude, it's going to be one of the 3 of these ones in yellow. Now you have 2 of them. You can just look at your book of truth and kind of match things up. All right, the second one does medium to big. It's the same thing. We take the hypotenuse of this one, the medium one, and it's going to equal to the whole thing, not times this piece. Now it's done. This is, for me, the right one. Okay? So this one is, this hypotenuse of the medium one is equal to the hypotenuse of the large one times the piece on the right. Is this what you thought it was? Okay.
This is conversion.
So I said we were doing 4 things. First one is how to do a geometric mean. You know that. And the other 3 are these 2 corollaries. And that's the, we're not going to stop right here, but that's the whole class, right? There's nothing more than this. The issue is they're going to give you examples now, and you got to apply these geometric means and the 2 corollaries. So we'll spend the majority of the class doing these examples. Now I realize this is the 11th? No, 10th time I've taught this. That it sticks with me right now because I've done it a bunch of times. I remember learning this the first time, and I remember being like, I'm never going to memorize this stuff. So for me, I didn't have a book of truth. It was a bit more of a challenge. For you, like I said, don't lose your book of truth and make sure you have this picture drawn. And by the way, this picture is the same picture as it was for corollary 1. Picture doesn't change. What changes are the geometric means. And if you can match the picture to the scenario that you'll have tonight for homework, then you'll be perfectly fine. All right, everybody at a level we can do some examples? Okay. All right. This is Turkish for, take a guess,
Stop.
for stop.
There.
So we're going to stop, and we're just going to do some examples, right? No more new stuff. All right. I always found that funny for some reason. Is this the same picture as the previous one? It is. It's easy if you can remember this picture. We get 3 things, right? The 4th one is just the overall thing of geometric mean. But the 3 things we have are, we think about this whole big triangle. We got an altitude, and we got 3 sides. We got an altitude, we got this side, and the hypotenuse, okay? So if we think about just the altitude, that's corollary 1. Corollary 1 says that this distance right here, Cn, will be equal to the square root of this piece times this piece. All right, it's a pretty cool pattern. You might not remember it, but that's all it says. Corollary 2 says 2 things. Corollary 2 says the other 2 pieces. So this piece is going to be equal to the square root of the whole thing times this piece. And then the second part says that this side follows the same pattern here, is equal to the square root of the whole thing times that piece. Okay? Does that help? For me, I had to do this. I had to memorize this thing. So I had to do this quite a few times to have it solidly stuck in my head. Because the actual math, and you've already done the math, that was, we did a geometric mean. The actual math is easy. But remembering these 3 pieces parts is the challenging. Okay, so here we go. Hey, does this look like our picture? It does. And why do I keep asking that? Because guess what they're going to do tonight for homework? They're going to take this and they're going to spin it, and that's what causes typically the problem. So if that's one of the things you have a problem, then take your book physically and flip it around so it looks like this. Okay, Bailey, tell me corollary 1. Anything you wrote down? Corollary 1. Tell me anything you wrote down. For corollary, you didn't write anything down? The picture, but you got to have what was in yellow. You have to have, here's corollary 1.
Oh.
You have to have that written down. So Cn is what part of the triangle? Okay, so here's our example. This is going to take a while. So where's Cn? By the way, this is on your paper about stuff. Where's Cn? H. So back here, H is equal to, what's it tell me to do? Where are these pieces? Okay, AN is you can use any word you want, times that's what I would say. Okay, so now we're going to go back to our example. So H is equal to, except you got to put a square root on it, right? So that wasn't too hard. So corollary 1 applied to this one will be H is equal to 3 times 7, take the square root. 3 times 7 is, so therefore what's the answer? That's the answer. You're done. Now, you got to be careful. Are there any perfect squares inside of 21? So you're done. You just did your first one. So the issues of that is you got to remember that. So maybe what I just showed you is helpful. Maybe it's not. But for me, I just go back to that original picture and just apply that thing. All right, Karis, you get corollary 2, the first one to corollary 2. What piece does it talk about first? And where is that on this? I'm sorry, did you say?
AC.
Right, and where is that on this picture? So A is equal to, this is corollary 2. There we go. A is equal to what pieces parts? Say again. And what's that on our picture? 10. You're almost there, times. So where I typically lose kids in geometry is that's what they can't do. All I'm asking you to do is follow a pattern. You did it perfectly, okay? 10 times 3 is there any perfect squares inside of 30? You're done. That's it. I mean, it doesn't get any more harder than that. Literally. It doesn't get any more harder than what you just did right there. Who wants the last one?
I have a question.
What?
The question is, when we're using these formulas with all these square roots, right?
Yeah.
And let's say we have numbers that can be square rooted before we even plug it into the situation. If simplified.
Yeah, absolutely. Do it. Do it.
Okay,
Yeah.
wonderful.
Okay, Cadence, you want the last one? What's the second part of corollary 2? And where would it be on our picture? B would be equal to
10, or the square root of 10 times 7.
perfect. 10 times 7 is
70.
any perfect squares inside of 70? So you're done. All right. I'm going to claim class dismissed. I don't need to do anything else because I picked 3 people and they got it perfect. Like literally, it was perfect. Why am I making a big deal about this? Because everybody does it. I mean, every class I've ever taught is exactly like this. Like you'll get it, and then you kind of go away, and then you don't get it. Okay. So I'm going to claim that if you follow the pattern that whatever it was going on in your head, you can do this. Okay. Connor, what's the problem with box 6? Okay, you get 2 options. You can either do what the girls are doing in the back, turning their heads, or you can do the smarter thing, which is take your paper and just turn your paper. Yeah? I'll give you that. Or I guess third option, redraw it. So if you redraw it, well, there's your redraw, right?
Is that a Z?
Well, when I turn it, it sure looks like a Z, doesn't it?
No.
Oh, yes, that's a Z. Sorry.
Yeah.
It's on your paper, by the way.
Oh.
Box 6. Okay. Connor, corollary 1. Apply corollary 1 to, I don't know, whichever picture you want. Or turn your paper. Is corollary 1 talk about X, Z, or Y? Z. Okay. So corollary 1 talks about Z. Now you just got to apply corollary 1 to whichever picture you're using.
I mean, 2 times 7.
In the square root. Perfect. Perfect. 2 times 7 is any perfect squares in 14? So you're done. Am I beating a dead horse at this point? You want to try corollary 2? Yes, you do. Okay. All right. Look, corollary 2 talk about X, Z, or Y, the first part of corollary 2. Talk about X, Z, or Y.
First part talks about 2.
Does it talk about X, Z, or Y? You're solving for one of those.
Oh. It talks about X.
Talks about X. Okay. So X is equal to?
2.
Say again.
I'm
You're right. X is equal to?
A. Wait, are we talking about?
You got to look back at your corollary 2.
Yeah, that's what I'm doing.
What's the first thing that has you multiply by? Where does that number come from?
A, B, and A.
Where does AB come from?
It comes from X.
Uh-uh.
No,
Where does
7 and 2.
and that is
14.
no. AB, look at your picture. AB was what part of the triangle?
The long part.
The long part. So what's the long part?
7 and 2.
Which is not 14.
Oh, I thought you were multiplying.
Yeah.
It's 9.
It's 9. Okay, so the long part is 9 times
2.
times 2. Perfect. Perfect. Now I'm going to show you a trick. You ready? Danny, you ready? It says we need to multiply by 9 by 2 and then take the square root, but I already know what the square root of 9 is. So this is really 3 root 2. You see what I did there? I mean, I could do 2 times 9 is 18 and then say what perfect square, but I'm going to go ahead and reduce right now. Danny, did you follow that? Okay. Chris, you got the second part of corollary 2? X, Y, or Z? What? Does the second part of corollary 2 talk about X, Z, or Y? Okay. That's the first part of corollary Y. That we just did that. It's a corollary Y and then corollary 2. You got to look. What? That's corollary 1. Yeah, but okay, we eventually got to the right answer. Yes, it talks about one, but I mean, you got to be able to look at truth and be able to do this, right? So it does talk about y. Y is equal to what's the corollary 2 say? The second part. What you wrote down in your book, it should say, give me the sides. I don't have it in front of me.
BC.
It says BC is equal to,
BN.
what's yours paper say? BC is equal to, okay, I'm going to go back to, you got to have this written down. You will not remember this. I mean, we're only, 10 minutes past me teaching it to you. You've already forgotten. You have to have this written in your book of truth. The people that haven't written their truth, they already know the answer to this. This is easy. I'm not getting on you, but I'm saying you got to have it written. You will not remember. Yeah, there is. Let's go back. Right here. BC, you got to have this picture though, because it would make no sense, right? This is here's corollary 1, here's corollary 2. BC is equal to what pieces parts? Let's finish this. Plus we got 2 minutes. BC is equal to what, Chris? Now where is AB on the picture? Yeah, but where on the, I mean, you gotta give me some descriptive words. Where is AB? It's the whole darn thing. Look, that's the whole bottom. AB. Okay. Times. Where's BN? What? Okay. Now we're going to go to your problem. So where is the first part of corollary 2 on this picture? Oh, I'm sorry. We're on this one. So on this picture, where are you? Sit, girls. This is the picture. I want you to do what you just did to AB and all that jazz to this. Where is that piece part? Y is equal to? Where's AB on my picture now? So how big is that? It's not 7. Okay. 9 times. Don't look at me, look at the picture.
You're confusing.
Okay. All I'm asking you to do is to take what you just wrote down furiously on your paper. This is the picture you got to have in your head, because this is the formula. but you got to apply this to a new picture that looks like this, except it's not called AB. It's called, maybe there's numbers, maybe there's variables. And you told me correctly, Chris, you with me?
Not really.
Okay, look up here. You told me that this piece, which is BC, is equal to the square root of the whole long thing times the 2/3 part. That's what you said, your words, right? Now, this piece right here is equal to the whole thing times the 2/3 piece. That's what it says right here. And you said that. Okay? I'm using your words. Now, I'm going to give you a new picture. It's not going to be called CAND. It's going to be called something else. And there's going to be variables and numbers all over the place. But you got to think about this applied to the new picture. Okay, here's the new picture.
So it's 9 times 7.
Okay, and that's going to be equal to,
I have no idea.
yeah, but why?
3. Square root of 64.
Okay. Are there any perfect squares inside of here?
9.
What's square root of 9?
3.
So what's the final answer?
3.
3 comes to the outside.
Tell me the answer.
I did. All right. With the exception of Chris and maybe Nanny, we good?
Yeah.
All right. You tell me, easy or hard? It was definitely an easy, hard class, but you guys did very well.
So I saw it.
I know, and I'm saying
Then when I saw it,
as soon as you see it, it becomes very crisp.
because I was stuck on the 20.
Hey, yes or no?
I don't know. Jesus.
Majority of the people here got this, right? Hear it from one of your fellow students during student advisement. You can get this, Chris. All right, anybody live today? Isaiah, you live? Who's live today? It is Jenna. Jenna, any questions?
Nope.
All right. Hey, Jenna, I'm not going to lie. I'm going to say this is hard. Hopefully you understood the process there. You got to apply that picture from the theorem to this new stuff. And as long as you can do that, then this is really easy stuff. But boy, does it take a while to understand.
Okay.
All right. Have a wonderful day.
You too.